So what if I told you that with this picture, and if we knew how many subscribers company A and B have, what if I told you we could predict how many subscribers each company will have in 1 year? So what we have here is a Markov chain, and in this picture it demonstrates the change in satellite subscriptions each year. And for context, this is for two companies competing in a city with 100,000 people. Company A has 15,000 subscribers and Company B has 20,000 subscribers. So let's get back to the question, how many subscribers will each company have in 1 year? Well, let's start out with drawing our probability or matrix of transition probabilities. So let's say we have P, and that's equal to a 3x3 matrix of A, B, none, and the rows will be designated as A, B, and none, where the row indicates from, and the column designates to. So let's look at company B. So in company B, from A to A, it's 70%. So we're going to convert that to a decimal, and that's going to be 0.70. Now what about from A to B? From A to B, we have 20%. That's going to be 0.20. And then from A to none, that is going to be 10%, which is 0.10. And you're going to notice that the matrix of transition probabilities, it should be stochastic in order for us to do this problem. Meaning, what exactly? Well, it means two things. Each entry should be inclusively between 0 and 1, and each column within the matrix should add up to 1. So we already did column A. Can we do column B? Let's pause the video and find that out. But if you want to follow along, that's welcome. So from B to A, we have 15%. So that's going to be 0.15. And from B to B, we have 80%, which is 0.80. And from B to none, we have 5%, which is 0.05. Hopefully you guys got that one. So we already did columns A and B. I'm going to actually let you guys do the third column for those without a salary subscription. So you should end up getting this matrix of transition probabilities, and we're missing one thing. How are we supposed to represent the proportions of the total population in 3 states? Meaning, how are we supposed to convey the subscribers in companies A, B, and none? Well, we're going to have to convey that as an initial state matrix, which can be denoted as x naught, which is equal to A, B, and none. Okay, so how many subscribers do we have in A? Well, company A has 15,000 subscribers and company B has 20,000 subscribers, and we're going to convert that to decimal. So let's divide that by 100,000, and we end up getting 0.1500 and 0.200. Now we gotta remember the problem, there are 100,000 households. So with 35,000 households already subscribed to either companies A and B, well, out of the 100,000 households, how many remains that do not have a salary subscription? And it's going to end up being 65,000. So we're going to convert that to a decimal, which is going to be 0.650. I didn't know, 0 for good measure. So we have the initial state and the matrix of transition probabilities. What's next? So, in order to find the state matrix that represents the portions of the population in the 3 states in 1 year, we should multiply the matrix of transition probabilities by the initial state matrix. What does that look like? It's going to look like this. So we'll have x of 1 for 1 year, which is equal to p times the initial state matrix, which is going to be equal to the matrix, the 3x3 matrix we just did, as well as the initial matrix we did a while ago. So here is our operation, and over here it's just a matter of matrix multiplication, and as a result, x of 1 should give us a column vector of 0.2325, 0.2875, and 0.4800. Okay, well, what does this mean exactly? Well, we have x of 1 is equal to this column vector for A, B, and C respectively. And in 1 year, company A will have this coefficient, and in order to have that information convey the amount of subscribers, what do? Well, you just multiply that by 100,000. And you do the same for company A, B, and those without any satellite subscription. So as a result, if you multiply each entry by 100,000, A will end up having 23,250 subscribers, B will have 28,750 subscribers, and C, which will represent those without satellite subscription, will be a pretty grand number. Let's see here. It will end up being 65,000 people in 1 year without a satellite subscription. And that is how we are able to solve the projection of how much each company will have within a given year. And you'll notice that the equation will follow a general pattern. So the end state matrix of Markov chain, for which P is the matrix of transition probabilities and x of naught is the initial state matrix, that can be represented as this expression, where x of n is equal to p of n times x of naught. So if x was 0, so let's say, if n was 0, we would get x of 0 is equal to p of 0 times x naught, which is just, x naught equals x naught. And what if we had n is equal to 2? Well, if n was equal to 2, we have this expression right here. And it's simply the P matrix times itself times the initial state matrix. But you're going to see that it's going to get a little more, it's going to get messier than that in the later sections. Okay, so what if we're supposed to find the number of subscribers each satellite company will have in 3 years, 5 years, 10 years, and 15 years? Well, let's remember the one equation we had, and that was x of n is equal to p of n times x of naught. We're going to have n represent the number of years, and for part A, where n is equal to 3, that is the same as, well, it's just a matter of direct substitution in this case, because we already have the value of P, and we already have the initial state matrix. Go ahead and plug that into your calculator, and you should get a good approximation of 0.3028, 0.3904, and 0.3068. And as a result, we have that in 3 years, Company A will have 30,208 subscribers, and Company B will have 39,040 subscribers. Now go ahead and drop in the comments how many people will still not have satellite subscription in the comments after 3 years. And you guys will be doing the same for 5 years. So if n was equal to 5, what do we do? Same process as always. It is simply x of 5, which is equal to p to the power of 5 times x of 0. You're going to get a rough approximation of 0.3241, 0.4381, and 0.2378. And after 5 years, Company A will have 32,410 subscribers. Company B will have 43,810 subscribers. Now, for those without a satellite subscription, after 5 years, what does that number result in? Go ahead and drop that in the comments too. And it's best that you guys get a graphing calculator for these problems, because it's going to be tedious multiplying the same matrix 5 times, especially by hand. Now, what if we had 10 years, where n is equal to 10? Go ahead and drop that, or go ahead and pause the video and do it yourself, or share your thought process in the comments. So this is what the operation should look like. Company A will have 33,330 subscribers, and Company B will have 47,560 subscribers, with the number of those without satellite communication being roughly the same as 10-15 years. Now, here's the thing though. So, oh yeah, we still gotta do the 15 years. So in 15 years, I'm sure you guys know what to do. So we're gonna let n equals 15 times the probability matrix to the 15th power times the initial state matrix. And you're gonna see that to do this by hand, it's gonna be a pain in the butt. But with a calculator, anything is possible, right? And there you have it. These are your projections after 15 years. So, yeah, Company A will have 30,330 subscribers, and Company B will have 47,560 subscribers. And here is where we notice an interesting pattern. So you're going to notice that there's a little difference between 10 and 15 years pertaining to the number of subscribers. So here we have n is equals to 10 and n is equal to 15. And you're going to notice that the difference is fairly minimal. And when you reach a plateau, and change in values, we approach what is called a steady state. That is as long as the matrix P does not change and the matrix product p to the power of n times x approaches a certain limit. So we have calculated the number of subscribers in 3, 5, 10, 15 years. And what we're going to do is we're going to take the average of all those values, the common factors for each n input. And what does it look like exactly? Well, when you take the average, that can be denoted as, let's see here. That can be denoted as a third, 10 over 21, and 4 over 21. And if you were to convert the fractions to decimals, we get 0.33. Repeating, it should be 10 over 21, my bad. We should have 0.4762 and 0.1905. This right here is your steady state matrix. And if we were to multiply the steady state matrix by the P matrix, what does that result in exactly? Well, it's gonna look like this. So go ahead and plug these values into your matrix or into your calculator and let me know what you get. And it turns out, you guys, that when you multiply the probability matrix by the average, well, it's not really the average, is technically a steady state. You are going to find out that the probability matrix times the steady state is equal to the steady state. And we're going to verify this later on. So what if we didn't know that that was an option, and we had to find the steady state matrix a different way? So let's use the same P matrix, and to find the steady state matrix, we're still going to use the equation P times the steady state matrix equal to the steady state matrix. And you're going to see equations in this format a lot. We already did that with ax equal to b and the like of it. And what that implies is that we're going to multiply p by a common factor of x of 1, x of 2, and x of 3, which is going to equal to the steady state matrix. And because this system is already set up as an augmented matrix, what if we convert it back into a linear system of equations? Let's do that. Okay, so this is what it looks like when we convert a system from an augmented matrix to a linear system of equations. But there's one more equation that we're not including here. And remember, P is stochastic. So what does x1, 2, and 3 have to add up to? And it turns out it has to equal to 1. And there we have it. We have another way to represent the problem at hand to find the steady state matrix. Okay, so since we're given two new ways to look at this problem, we can resort to whatever means necessary to find the solutions for x1, 2, and 3. We can do that via substitution, elimination, or Gauss-Jordan elimination. And you're going to get that it's going to be the same as what we got earlier right here. So I'm going to end the video right here, and if you guys confirm it, if you guys do the work and you confirm it, feel free to drop that in the comments and share others your thought process, because I'm sure we would all like to hear it.